Hello. In this video, we'll talk about how to convert probabilities to quantiles using R. So if we look at this figure, it shows a probability density curve for t distribution. And on this axis, or we call this is the quantile or the t value. So here t alpha is a quantile value, or maybe here minus t alpha is a quantile value. So for each such value along these random variables available value, they will have a probability on the left side. So for example, for the t alpha, on the left side of this quantile value, the cumulative probability is this white area, right? And this white area, because alpha we can define, for example, is 0.05, very small number. So this white area has 0.95 in probability. So we call the cumulative probability for this quantile value is 0.95. And we can use the function. So quantile value means the probability of random variable less than this value x. X here is p. So which means how much percent of all the random variables in this distribution less than this value. So this is called quantile value. And in R, there are built-in functions for quantile values starting with alphabet Q. So for example, qnorm is for calculating the quantile value for normal distribution. So qnorm 0.05, mean 100, SD 15, which means we will calculate a normal random value with the cumulative probability is 0.05, and this normal distribution has mean equals 100 and standard deviation 15. So if we look at back, if this is a normal distribution, so this quantile value may be here, right? Because the 0.05 on the left side of this value. Then we go to RStudio to show how to use these functions. So for qnorm 0.05, mean equals 100 and standard deviation 15 is 75. And now you can see the quantile value often used to calculate the confidence interval. If you look at this figure again, for example, if we want to draw the confidence interval for the population of a distribution of a population mean, we get the sample and we get the sample statistic. Then this sample statistic will return the t value here and here. So we can get the sample statistic for the t value or t quantile value here. Then we can calculate further, get the confidence interval for the population is around this range, right? For the population. So this is one of the main usage of using the quantile value. So for example, we want to draw 95% of the confidence interval of a population mean. Then we have to calculate because alpha is 0.05, because 95% for the confidence interval, which means 95% is the probability for the significance level. So this white range represents 95% of the significance level. So which means we have alpha 0.05, and on two sides, which means the white area on the left side of this critical value is 0.025. And the right area or the blue area for this critical value is also 0.025. So in this case, we have to calculate the quantiles of zeros, 0.025 and 0.975. Right? So we use quantile. So if we do not set any parameter for the mean and the standard deviation, so I will think this is just for standard normal distribution, which means mean is 0 and the standard deviation is 1. So this is for the minus 1.96 and 1.96. So this is why in confidence interval for standard normal distribution, or we use normal test, usually we just use 1.96 because these two critical value here is 1.96 and minus 1.96, which will make area on both sides is 0.025. And next we show the example for the t-distribution. And t-distribution is quite similar as normal distribution, just has a little flat shape and a longer tail on both sides. Also symmetric in this probability density curve. And for the t-distribution, for example, we want to calculate the quantile values associated with a series of cumulative probability values. So we first create a vector from 0 to 1 and with the gap 0.2, which means we want to calculate the quantile values for probability from 0 to 0.2, 0.4, 0.6, and 0.8 and to 1. And we set the degrees of freedom 5 because t-distribution, the parameter is only for the degrees of freedom. Has no mean value, no standard deviation. It's only for the degrees of freedom. So next we can use quantile value for this series, this vector of cumulative probability, and with this degrees of freedom and qt, which means the quantile value for the t-distribution. Then we get this quantile value and plot in the y-axis and axis for cumulative probability. So this is the result of this plot. So you can see for the probability 0.2 is a very low value for the quantile, is about 0.1, something like that. And for cumulative probability 0.4, its value is about, sorry, here is minus, so it's the, this is minus 0.9, right? And for cumulative probability of 0.4, its value is almost minus 0.2. So which means there are about 40% of all the values in this t-distribution with 5 degrees of freedom are less than minus 0.2, right? And for 0.6, it gets the value about 0.3 here. So which means about 60% of all the values in this t-distribution are less than 0.3, right? And of course, this point is increasing. So almost 0.9, right? 80% of the value less than 0.9. And we can see this is almost 1 here to here, and about 0.85, right? To 85% of the value less than 1, right? So we have to think opposite way. Thanks for watching this video about quantile values.